Okay, welcome back. It is day 137, I believe, of programming every day. Um, so today I met with my partner for computer architecture, um, and worked on, honestly, talked most of the time, but I was trying to fix the visualization on the pipeline of once all the instructions finish going through the pipeline, it should just say no op for each stage as the pipeline gets flushed. Um, so how I was trying to do it beforehand was if the instruction was zero, meaning so DRAM is loaded with all zeros. All right now I have like 1,000 slots in DRAM, and it's all 16-bit zeros. And so I had it that if that instruction line of all zeros was at like any stage of the pipeline, then you would return or print to the API. You'd print the current stage and then no op. And so ideally, the interface would then get that result or that response from the API and display no op. And so that worked for everything except for write back because I didn't have it set up to take in the actual instruction. So then I changed it to take in the actual instruction, and honestly, don't know why it wasn't working. It just was not working. So I ended up figuring out um, that if you took, by the way, I did this earlier today, and then like not in the recording in the background, and then I recorded when I went to the cafe, like I don't know, 2 hours ago. But so it just checks the if it's valid, right? If we don't have a valid instruction, then what we do is we set the next register to false for the next set of things, but then we do the response, or we send the print statement to the API of, hey, this is a no op, um, and so then that gets sent there, and so that should ideally still, I don't know. Well, I mean, it's working now. I'm thinking like later with like branching stuff. If there's a no op that goes in, it should still work. But I mean, it's working now to flush out the pipeline. So that's great. And then at the very end of the recording in the background, I worked on branching. So the assembler is the exact same, but ended up changing execute to include all the instructions that we want. And so branching with a register immediate, right? So if we have register 3, which is a value of, I don't know, 5, and then we have an immediate of like, or no, 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 no. I think it's a register immediate would be program counter is what we're using, and then yeah, and then the immediate would either be skipping ahead or going back. So like a for loop might be a register immediate of like let's define like a branch not equal, right? So we say we start here, then we do this, this, this. If branch not equal, then take the program counter register and -4, and then go back 4, and so it'll keep going back until that branch equal is equal, and then it'll just go forward. So I think that's working as well. The only thing that needs work now is the shift, because it's supposed to be in the instruction set. We had it 2 bits for the type, but I don't. It leaves us with 2 extra bits, so I'm just gonna make the type field 4 bits. So that needs to change. But other than that, everything should be pretty good now, and we can start working on like benchmarks and hooking up the rest of the UI. So good progress today. Really good progress. As for the rest of this week, again, still just more computer architecture. And then this weekend, we will start a probably personal project. Oh, and I looked at the computer system principles project, and that was parallel processing. So we'll probably do that this weekend while we try to figure out a personal project that I can work on. Um, so yeah, so that is all I have for today. Um, I will see you tomorrow with a day 138, I believe. So, okay. Bye.